let's examine some graphs of functions. Okay, first of all, domain is the set of x values. It's the set of x values that are allowed to go in and be used, the set of x values used. And range is the set of y values, the set of y values used. So what we're going to start doing now is look at graphs and determine some information like domain and range, not algebraically, but from their picture. F of x means y, so whenever you see that, that's like the y. Interval notation symbols, we've already gone over this a little bit, but if you're going to include something with a closed bubble, then you use brackets. Not include, you use parentheses. Okay, and then if it's infinity, negative infinity to positive infinity, you always use parentheses on them. Okay, and they always go small, comma, big. That's how that's going to work. Okay, so here's our great picture, and we're going to answer some questions about it. When it says f of 0, what they want you to do is put 0 as the input, and they want you to come up with the output. When I say input, does that mean x or y? Input is the x. So if I put 0 in, here's the point on the graph, 0 in, 4 comes out. F of 0 is 4. Let's try it again. F of 3 pi over 2. If I put 3 pi over 2 in as the x value, then 0 is the output. Okay, last time. What's f of 3 pi? You put 3 pi in, here's the point, and negative 4 is the output. So that's function notation from a picture. Okay, what is the domain? Remember, domain is the set of x values. So we are going to start on the x-axis all the way as small as we can go. So on the x-axis, and you back it up all the way to the left. You're going to look left to right. What's the smallest x number being used? The smallest x number is 0. 0 is the smallest x number. Does it touch 0? Is that an open or a closed bubble? Since it's closed, I'm going to use brackets. 0. Now, does it go forever? I see this graph, and it only goes to here. What's the largest x value that it uses? 4 pi. 4 pi. Does it touch 4 pi? Is that a closed point? Since it touches, you're going to bracket it up. Okay, so x values, you look along the x-axis from left to right. All right, let's take a look at the range. The range means the set of y values. Now you find the y-axis. Here's the y-axis, and you go down as low as you can. So y-axis, we're going to go from small up to big. The high numbers are up there. So what's the smallest y number? The smallest y number is negative 4. Does it touch negative 4? Yes, that's a closed point, so let's use a bracket. And then comma. What's the highest this graph can reach? The highest, I think those are all the same. The highest y value is 4. Lots of 4s. Does it touch? Yes, so you do brackets. So to state the range, you go up the y-axis from small to big. Okay, we are going to do this for a couple of days. So if you're not quite sure visually what's going on, ask lots of questions and I'll help you. Intercepts. Okay, remember, intercepts are points. So we're going to name some points. Here's an x-intercept. Pi over 2 comma 0. Here's another one. 3 pi over 2 comma 0. Here's another one. 5 pi over 2 comma 0. Here's another one. 7 pi over 2 comma 0. Oops, I missed one. What about the y-axis? There's an intercept at 0, 4. So don't forget to look on the x-axis and the y-axis. Now they have a question about how often does y equals 2 intersect? What is y equals 2? Y equals 2. That is the equation of a line. That's a hoy. That's a horizontal line. So I'm going to go to 2. I'm going to draw this horizontal line for you. Y equals 2. Now that you see the line y equals 2, how many times does it intersect the graph? 1, 2, 3, 4 times. That was an easy question as long as I remembered what y equals 2 looks like. Okay. For what values of x does f of x equal a negative 4? Okay, I have to make sure I think about this the right way. Negative 4 is the output. That's the y value. So I'm trying to think about comma negative 4. I'm thinking about that kind of a point. For what values of x? So my answer is going to be x equals. I'm looking for some x's. Are there any times that I have a y of negative 4? There's one at x equals pi. And here's one at x equals 3 pi. Okay, so having the points labeled sometimes makes it really easy. We're not always going to have points labeled. We'll have graphs, but we're going to think about it the same way. And finally, for what values of x does f of x be more than a 0? Okay, sometimes this is really easy to think about if I cover up the graph. I want the graph to be more than 0. So it's going to look like this, more than 0. You're only allowed to see the graph above the x-axis. Can I equal 0? Since it says greater, you cannot equal those points. That's going to be an open bubble, open bubble, open bubble, open bubble. You cannot equal 0. You have to be greater. So here's some graph that's greater. Here's some graph that's greater. And here's some graph that's greater. Okay. Now how am I going to say all those pieces? Definitely going to use interval notation. Okay. And I'm going to start on the small side. So let's start way over here. Okay. It starts at x value. What x value? It starts at 0. Can I use that point? Is that point more than 0? Absolutely. That's a good point. That's a closed point. So bracket that up. Okay, comma. And then we're going to keep going and going until I get to here. Then the graph is less, so I'm not allowed to say that. I have to stop right there at pi over 2. Now, is that an open bubble? Yes, because it says greater. I cannot equal that. That's where it touches 0. So parentheses or brackets. Let's put a parenthesis. Okay, but that's not it. Here's another piece that's more than 0. So say union. Let's start right there on the small end. 3 pi over 2 with parentheses because that's an open bubble. And it goes all the way until what x value? 5 pi over 2. And that's another open bubble. Okay, union, there's another piece starting right there at parentheses 7 pi over 2. And it goes all the way to there. Is that point greater than 0? Absolutely. So at 4 pi, brackets or parentheses, that's going to get a bracket because it touches and it equals. So let's take a look at some more. Here is a more algebraic approach. We have a rational function f of x is equal to x plus 1 over x plus 2. Question A, is the point 1, 1/2 on the graph? Well, what this means is 1 is an x value and y is the 1/2 value. And is that on the graph? So I think what I'll do to test this is calculate f of a 1. I'm going to put 1 as the input, and I'm going to see if I get 1/2 as the output. Okay, so if x is a 1, my input is 1 plus 1, my input here is a 1, and I get the answer of 2/3. Well, that's not 1/2, so the answer is no. Okay, part B. If x is 2, what is f of x? So now they want me to put 2 in as the input. If I put 2 in, 2 plus 1 is 3/4. The output is 3/4. What point is on the graph? Well, that's easy. It's the point 2, 3/4. Okay, so you could do some point work. This next one is a little backwards. It says f of x is 2. So 2 goes into the f of x spot. This is like the f of x is like the y. 2 is going to go right there into the f of x spot. So 2 goes in for the y value for the f of x spot. X plus 1 over x plus 2. I'm going to put 2 over the number 1. And we can solve this if we cross multiply. When you cross multiply, you get a left side or right side with an equal sign in between. So let's cross this way first and get x plus 1. Let's cross the other way and put that answer over here. It's going to be 2x plus, oh, don't forget to distribute the 2. That's right, of 4. I think I'll move x's to the right. Minus x, that's x. Minus 4, I got -3. So it says, what is x? X is -3. But then it says, what point is on the graph? So give me an x, -3. Give me a y. The y value was 2. That's the point on the graph. What are the x-intercepts? Oh, here's some great review. To find an x-intercept, we're going to let y equal 0. Where's the y? The y is the f of x spot. So 0 equals, it's kind of like the problem we just did, except I'm plugging a 0 into the y spot. Let's put 0/1 across multiply again. X plus 1 times 1 is just x plus 1, but 0 times a whole bunch of stuff is 0. So x is -1. Wait a minute, you're not going to write that down as the answer, are you? I hope not. An intercept is a point, -1, 0. Okay, what are the y-intercepts? To find a y-intercept, we let x equal 0. So y equals 0 plus 1 is 1, 0 plus 2 is 2. Okay, once again, let's make sure we state our intercept as a point, and it's the point 0, 1/2. So there's some algebra review. All right, we got one more example down here, and here's a picture. I want to look at this picture before I answer a bunch of questions about it. The first thing I notice is that it's going up, up, up. It's getting closer and closer to that dotted line, but it's not touching it. That is called an asymptote. This graph is never going to quite touch that value right there. I see some x-intercepts. Oh, notice that hole. Okay, some y-intercepts, and then the graph stops right there. What is the domain? Okay, so once again, domain is the set of x values. And you look along the x-axis from left to right. So let's look at the farthest to the x-axis we can spot. Does this graph stop at -9 or -10? No, it goes all the way to -infinity. Does the infinities get parentheses or brackets? It's going to get a parenthesis. Okay, and then the graph goes and goes and goes, but wait a minute, there's no graph there. The question is, what number, what x value is that number? 1, 2, 3, -4. Sometimes it really helps people to write the coordinates down. And then I could say, what x number are we going to stop at? And the answer is -4. Now, since that's a hole and it's not touching, so use parentheses or a bracket. Let's use some parentheses. Okay, but now there is more graph. So how do you say and? Union. And you're going to start right there at that hole again. So parentheses -4. Okay, the graph starts at -4 and goes and goes and goes and goes until here. So some people like to just kind of look along the x-axis. or some people like to actually write the coordinates down, 8, 2, and the largest x value that's used is 8. Does it touch there? Absolutely, so we're going to bracket it up. All right, let's do it again, but let's do the range. Now the range is the set of y values, so you're going to start on the bottom of the y-axis and go up from small to big. What's the smallest y? Is negative 10 being used? Negative 9? No, the smallest y is this value right here on the y-axis. That's negative 4. Does it touch negative 4? And the answer is yes, so we're going to bracket it up. And what's the largest y? Does it keep going up, 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 up to infinity? No, the highest number that it touches is 4. And you bracket it up. So you're looking up the y-axis. The highest y value is 4. Sometimes people like to see 6, 4, and then they know that the y value is 4. Okay, intercepts. Let's take a look at all the intercepts. I see an x-intercept right there at negative 6, 0. I see one right there at 3, 0. I see a y-intercept at 0, negative 3. And I believe that's all. How often does the line y equals 2 intersect the graph? So that's a y equals 2. Let's draw a horizontal line here. Now I notice that the graph is getting closer and closer, but not touching 2 there, not touching. It does intersect 1, 2 twice. Here's some questions about plugging in some points. F of 3. So 3 is the x value, that's the input. So I'm looking for 3, something. So if I go to x is 1, 2, 3, there's a point right there. That's the point 3, 0. So that would make f of 3 a 0. You put 3 in, what comes out? Here 4 is the output. The question is, what is a? What's the input? I do see this point right here. 4 is the output. So the input, a, must be a 6. Okay. F of negative 4. So let's go to negative 4. 1, 2, 3, 4. Oh, right there. Do you see that open bubble? Do you see how it's open and it's empty and the graph is not touching there? So f of 4 is no solution. Because it's empty, there is no graph. That's a tricky one. And here we are again with f of x being greater than 0. So the first thing I'm going to do is make sure I get out a piece of paper. So I'm only allowed to see the graph that's more than 0. That means I want the graph above the x-axis. Do I want to equal the x-axis? It says greater, so I don't want this, and I don't want this intercept. I don't want to equal 0. I want to be greater. So here the graph is greater. Just highlight it, greater, greater. And here the graph is up, up, up. Okay, the graph is up. All this graph is below, so we're going to cover that up. I don't want to see any of that below. How many pieces of answer? We're going to have 2 pieces of answer. The first one starts way over here. Okay, go left to right. So that arrow is pointing way, way, way forever. That's negative infinity. What do we always put on the infinity signs? Parentheses. Okay, comma. And it goes and goes and goes until that open bubble right there, which is negative 6. Since it's an open bubble, we'll use parentheses. Okay, is that it, or is there some more? There's another piece right here. So how do you say and? Union. Let's start right there at 3, since it's an open bubble, parentheses, and it goes all the way to x value of 8. Is that point greater than 0? Definitely. That point is definitely greater. I can use that. Since it's used and closed, we're going to bracket it up. Can you get information off a graph? I sure hope so.